Today we'll be studying conversions between metric and customary systems. Yesterday we studied the metric system, yesterday we studied the customary system, and the day before we studied the metric system, so today we're putting them together. As always, you're taking notes, and as we go along I'm going to give you a piece of information. When we're dealing with the conversions across systems, and when I say across systems I mean metric to customary or customary to metric. When we're going across systems, I do not expect you to memorize these tools anymore. They used to be required. Now that you just need to know that if given information like this, you can apply it using ratios or problem solving, but this week is ratios. So given that in length, 1 inch is equal to 2.5 centimeters, I do want you to record this, by the way. 1 yard is equal to 0.9 meters. 1 mile is 1.6 kilometers. In capacity and volume, 1 quart is almost a liter. It's 0.9 liters. 1 gallon is 3.79 liters. And then in mass and weight, 1 ounce is 30 grams, and 1 pound is half of a kilogram. So this will be on the screen each slide we go through because this will be the given information. So our question states, how many meters are on a football field if there are 100 yards? So what you'll do is first of all realize that we're dealing with meters and yards. So that's your first clue that we have to figure out what relationship meters have to do with yards. And using your information over here, I know that with length, 1 yard is equal to 0.9 meters. So that's the first piece of information I'm going to record. So 1 yard equals 0.9 meters. And we're trying to figure out how many meters there are if there's 100 yards. And X is my unknown because I don't know how many meters 100 yards is. Now obviously, I'm just going to go today with this problem straight across with equivalent fractions because I know 1 yard to 100 yards is times 100. And I'm going to do the same thing with my 9/10 of a meter. Multiply it times 100. And when I do that, I'm basically moving my decimal 2 places to the right. That's coming from 2 days ago. 0.9, 2 places. So my answer is 90 meters equals 100 yards. And that's how you go about comparing across systems. So it's the same thing we've been doing. You're just still using ratios, but this time you're going part to part instead of part to whole. So our next problem, so again we have our same information. The next problem is, if Sarah weighs 156 pounds and Sally weighs 59 kilograms, who weighs more? So again, we are talking about pounds and kilograms. So I'm going to look at my information and find out that 1 pound equals a half a kilogram. So I'm going to record that. 1 pound equals half of a kilogram. So now there are 2 ways. I can either at this point say 1 pound equals 156 pounds because I can put I do know my pounds up here, so I'm probably going to go that a little bit easier. So I'm going to take this piece of information, and what I'm going to do now, so this is 1 pound, and this is for Sarah. So I'm going to put Sarah's name so that I remember this is Sarah. Sarah's in the pounds. So if I go across for equivalent fractions, 1 pound times 156 equals 156. So times 156. And I'm going to do the same thing to the bottom to find the equivalent fraction for this, the proportion. Let me get my calculator. It's the broken one. Okay, so this time it'll be 0.5 times 156, and that's going to equal to 78 kilograms, because I know that this is kilograms down here. So again, multiplying straight across. So now this says, what my answer tells me, that Sarah weighs 156 pounds. And going by that ratio, this tells me that Sarah is larger. So Sarah equals 78 kilograms. Well, Sally weighs 59 kilograms. So Sally is less than this number, which tells me that Sarah weighs more in this problem. But then Sarah is 156 pounds or 78 kilograms, and Sally is 59 kilograms. So I'm going to put Sarah 78 kilograms, because all of this is Sarah's information. Well, not equals. Put our circle there to compare. And then Sally is 59 kilograms. And I can see that Sarah is larger in this problem. Back to my original, I could have said 1 pound is equivalent to 0.5 kilograms and put Sally's information in here and put Sally as 59 and then solve to find out how many pounds the Sally is. But I decided to go with Sarah. I just chose that one. Okay, let's do one more. So this time, if Bob ran 2.5 kilometers and Rob ran 1.7 miles, who ran farther? So this is a very similar question. This time we're dealing with miles and kilometers. So I'm going to put my unit ratio. Have to start with that. That's your piece of information that you know. So 1 mile is equal to 1.6 kilometers. And so again, I'm going to stick to the mileage one because it's easy to multiply. So 1.7 miles is equal to some number of kilometers. So I'm going to multiply. To get there, I'd multiply by 1.7. Do the same thing to the bottom. 1.7. So with my calculator, 1.6 times 1.7 equals 2.72 kilometers. And this is for Rob. So Rob ran 2.72 kilometers compared to Bob, who ran 2.5 kilometers. And by this comparison, I can see that 2.72 kilometers is larger than 2.5, which means that Rob ran farther than Bob. So I hope that helps. Again, it should just be a continuation of what we've been studying with ratios. Taking what you know and putting it into your unit ratio, and then filling in the information that you have, and the X goes where you don't know.